All right, welcome back. Okay, so in the last video, we were talking about formulating research questions and how they have to be specific and measurable and kind of pointed, right? We're not trying to be ambiguous with our research question. We want to be specific and concise. Okay, now in step two here, we're going to turn that research question and put it into more mathematical terms to make our lives much easier, I promise. Now, instead of me just telling you the definitions of these things, because that's very boring, let me give you an example, because I think that's the best way to do it. So in 2005, brown thrashers made up 38% of all the birds in northeastern Wyoming based on a proper sample. Okay, so it was done properly. This is the brown thrasher, very pretty. This number is actually real. However, of all birds, I'm being a little bit general here. There's more kind of detail that goes into that. This is not a biology class, though, so we are not going to worry about it. Okay, so 2005, the proportion was 38%. Being 15 years later, right, it's 2020 now, a Wyoming state ornithologist suggests otherwise. They suggest otherwise. They don't think that it's 38%. They think that it's something else. They don't know what it is, but they don't think that it's 38%. Okay? So then they go collect another more up-to-date sample, and they find that the brown thrasher makes up 34% of that sample. Okay? 34%. So take a note of the order here. First they suggest otherwise. They have an opinion first, and then they collect data. It's not the other way around. They don't collect the data and then think of an opinion. It's the other way around, right? Think of your opinion first, and then go collect the data. Okay, so that's fine. So maybe a 4% drop is a big deal. Depending on how many birds there are total, that might be a ton, might not be a lot. Either way, they noticed a difference, right, after formulating their opinion. Now, did the ornithologist's sample occur by chance? Or is this difference a true difference? Okay, so we have this sort of idea of challenging the status quo in hypothesis testing. And the whole deal here is that both of these are estimates, right? This one is the status quo, and this is our sort of known value, whereas this one is a challenge, right? This one is challenging the norm. And recall that in the central limit theorem, this idea, this founding idea in statistics, that these proportions, these sample proportions, come from a distribution that look like this, right? Where we really don't know what the mean is in the middle, but we could assume, we could assume that it's 0.38. That might be our assumption. And now we want to know, well, where does this 34 fall? Did we, and let me erase this too, just so I'm not confused, based on the sampling distribution of the proportions, fancy word, but really it's not too complex, but does this 34%, did it just show up out here? And is the actual mean closer to this 0.38? Right? Did we by chance accidentally sample something that was way out here in the tail? Something that has a low probability of happening, but still can happen, where all of the other sample proportions are closer to the status quo? What's the chance of that, right? How can we trust that this is real? How can we trust that this is real and didn't occur by chance? Well, that's a great question. And the first thing that we need to do to answer that question is come up with our two different hypotheses. Our first hypothesis is the null hypothesis. Null hypothesis. And all that's saying is a statement of nothing happening. That's a statement in this case of the status quo, of the norm, okay, of the status quo, right? So in English, the null hypothesis is the proportion of brown thrashers is 38%. We saw that here, right? That's the status quo. And we typically write it like this, where we use this H naught. gracefully written. Or H0. You can call it either way, but this is typically the convention. H naught. Okay? All right. So that's our null hypothesis. This is the, and I'll write it up here too, status quo. All right? This is just saying nothing is happening. Nothing is happening. Okay? What's our other hypothesis? Well, you can probably already tell that it's just going to be a challenge to the status quo. In this case, we can kind of say that it's like an opposing claim. It's an opposing claim. Now, notice sort of the vernacular here. The proportion of brown thrashers is not 38%. Or 38% comes here. It has nothing to do with this new value. Nothing to do with this value that was just calculated. It only has to do with the status quo, okay, which in this case is a proportion of 0.38 or 38%. And we write that in the same way as we write the null hypothesis, H naught, except that we use HA, H sub A if you want to say. And the only thing here that's different is the sign. I'll zoom in here too, right? All we're saying here is that the proportion of brown thrashers does not equal 38%. Or the proportion does not equal 0.38, okay? And then, simply, all we need to do is write it like this, okay? Where here is, let me get the actual thing. Here is our status quo. The proportion of brown thrashers is no different. It is what it is. It is what it said it was, okay? And then the alternative hypothesis is something that challenges that status quo, which in this case, notice that the vernacular is all the same, the value is the same, and the only thing that's different are the signs, where this one says what it said in the statement, and this one is what the researcher is claiming. Okay, so in this case, we have no directionality to this statement. This is sort of like, this is the way I like to explain it, this is sort of like arguing with a younger sibling. You say something, you're here, you say something, and all they say, nuh-uh, and then you ask them, well, what do you think? And they say, I don't know, right? That's it. That's all this is saying, right? In this case, we have no directionality to it. We just totally disagree. We totally disagree with this. It's not 38%, and I don't care what you think. It just isn't 38%, right? That's all this is saying. However, we can be more pointed in the direction, right? In this case, the state ornithologist, all they said was, I don't think so, right? However, there could be some direction to it. Maybe they're driving to work every day and they notice that there are less brown thrashers that they see driving in the morning, right? So then we would say, okay, maybe instead of it not being 38%, maybe we think it's less than 38%, right? That could maybe be one way we could think of something else, right? And the same is true on the other end too. Maybe they saw more brown thrashers than normal. Then all that's going to be is a change in the sign, right? Easy enough. Easy enough. Now, typically, the math doesn't really change. I'll show you why in a little bit. I'm going to make your life very easy, I promise. We typically, or at least in this class, typically will only work in this realm, where we think that it is not the null hypothesis. We do not think that it's 0.38 in this sense. We won't add any direction to it. However, it's only one extra step in the math if we want to add direction. I promise it's not difficult. In fact, it's only dividing some value that we're going to get in a little bit by 2. If you know how to divide, you don't even have to know how to divide. You just have to have a calculator, which is great. But let's talk about this directionality a little bit more. Okay, we have this idea of tails. And I'll draw it out like this again. Whoop. So our distribution always looks like something like this, and when we get into the actual hypothesis testing, the math side of it, we have to choose whether we choose this tail, right? All the tail is sort of the outer edge of our distribution, or whether we choose both of them, right? So one tail is when we only say, okay, there's a direction and it's over here. Or one tail and the direction is over this way. Two tail is when we just include both of them. Okay, and you can kind of see that here, right? So a two-tailed test is just when we say HA is not equal to, right? And fill in the blanks here with whatever there may be, right? The one-tailed test, as I was saying earlier, can look like this, where we think that something is greater than something else or less than something else, right? Now again, typically we work in this field here rather than these two, because these two can get complicated quickly if you don't know the trick with the two-sided test, and I'll tell you the trick in just a little bit. But that's going to be it, right? That's it, right? This is how you want to sort of state your hypotheses. So when it asks, state your hypotheses, this is the form that you want, okay? H naught, HA. Okay, so I'm going to pause it. I'm going to see you back here in just a little bit.